Fabulous chemistry students, here we go again. Video 6, we are halfway through. We need to study periodicity today. We are going to find a little bit about a new word that's going to come up a lot in the next 5 videos, okay? Um, is it beneficial to know patterns and cycles? Well, yeah, we have this notion of daily, weekly, and yearly cycles for our lifetimes, right? We can remember one year from the next based on, whatever it was, the birthday presents that we got that year, or the classes that we took that year, or that teacher we really hated, like Mr. Milks, right? But we do that in our brains normally if you think about it. Why is the periodic table periodic? Well, because there's cycles in the periodic table, okay? So as I move across a period, all right, what's going to happen is the nuclear charge is going to increase, and we found that it increases by 1 proton every time we go, okay? Well, this is what's key here, okay? As I go across, they can pull the electron cloud more tightly. We're going to find that comes up into a later video. Think about it as a bunch of positive magnets. How many paper clips can one positive magnet pick up? Well, maybe a few. But if I had 8 positive magnets, couldn't I pick up more paper clips? Okay? So that's why the nuclear charge increases, okay? Shielding does not increase, and we don't really know what shielding is yet. So you're just going to have to believe me that it doesn't increase, and on the next slide, we're going to get into what it is. But you need to know, as I go across the period, shielding does not increase. That's because I don't have any other energy levels, okay? This is a little diagram that you have in your notes to talk about shielding, okay? In the middle, I have the nucleus, and it's orange. I'm going to put some red on it, because red and orange are kind of like that's where all my protons are, okay? I have a neon shell and a hydrogen shell. So this is just basically saying, if I'm an electron out here, all right, and I probably should do that in a different color so we can not be the same color as our nucleus. This is basically what shielding is all about. This middle piece is all full of electrons. Well, this electron out here and this positive in the middle, there's this interference, if you will, of electrons, a buffer that make it so the positive charge in the middle is not as great on this negative charge out here, okay, because it's kind of convoluted, if you will. So let's go back to this magnets and paper clips scenario. If I have 2 magnets and I've picked up 40, well, let's start small. Let me do it small. If I have a magnet and I pick up 10 paper clips, and there's 10 paper clips all around it, can I easily pick up another paper clip? I mean, is it going to feel the magnetic power, right? So yeah, it's probably going to do it. But what if I have 100 paper clips all around the same magnets? Then I go to do another magnet. I mean, eventually there's going to be so many magnets, or I'm sorry, so many paper clips around my magnet that I can't feel that other paper clip as I come to it. The magnetic field of the paper clip or of the magnets is being interfered with, and the paper clip just doesn't want to be picked up anymore. Okay, so as I move down a group, right, my nuclear charge, of course, is going to increase, but not by 1 this time. All right, it's going to increase by more than 1. If I look at lithium, lithium has 3, okay? Lithium has 3 protons. And underneath lithium, I have sodium. And sodium has 11. So I'm not going up by 1 anymore. But as I go down, right? As I go down, I have an electron configuration here of 2, 1. And here I have 2, 8, 1. So what have I actually added? I've added a bunch of protons, but in this case, I've added this extra shell. So this, of course, is in period 2, and this is in period 3. So I told you at one point in class, and I hope you remember, but I'll tell you again now, this 2 has 2 energy levels, and the third one has 3 energy levels. So this increase in energy levels from the 2 that are around lithium to the 3 that are around sodium, adds this other layer of electrons, which adds this buffering effect that we talked about before. So that is what we mean by shielding increases. As I go down, as I get wider because I'm putting on more layers of an onion, I like to think of putting on more winter coats with pockets. I put the electrons in my pockets, right? And if I put on 4 winter coats, I'm kind of walking around a little bit goofy. And I like to think of the little brother, right? And A Christmas Story. I can't put my arms down. I can't put my arms down. Right? You put on too many coats. That's how you're going to feel. But you could put pockets, or you could put electrons in each one of the pockets, and that would be your energy levels. So as I increase, as I go down the periodic table, shielding is going to increase and atomic number is going to increase. As I go from left to right, the atomic number is going to increase by 1, but shielding does not increase because I'm in the same energy level. I still have the same number of coats on. Okay, so that is the pattern with periodicity that we are looking at today. You got some more practice packet question pages you can do, and we are done with this video. See you tomorrow.